All right, let us review quiz number 3 in Audio 1. The first question was about transducers, and a transducer is any mechanical or electrical device that changes one form of energy into another form of energy. And most often these are microphones and speakers. They're both doing the same process, just one going one way and one going the other. They are both transducers. The next question, it turns out it's true that there's another transducer, the ear. So our ears are actually also acting as transducers. They're taking sound energy and creating it into the nerve impulses that go into our brain. Okay, waveforms that we look at, those are graphic representations of sound pressure level or voltage level. Ideally, they'll be very similar, right? We're just, again, using a transducer to change one into the other as it moves through a medium over time. So you see it compared to time. Amplitude is the distance above or below the center line. So that's, I'm going to try very hard not to use the word volume too much because, yeah, that's more of a perception of loudness, but I'm certain I will use it often enough. But when we're being technical, we want to say amplitude, right? Frequency is the rate at which a sound repeats within a cycle. So frequencies are pitches, right? That's the again, as our perception of it would be the pitch. So low frequencies are low pitches, the low sounds. The high frequencies are the high pitches. And they're measured in hertz. We're going to talk a lot about hertz and kilohertz, and a little surprised that isn't one of our questions. It might have been earlier, I forget. Anyway, the speed of sound traveling through air at room temperature at normal barometric pressure is around 1130 feet per second, or 344 meters per second. Yep. Phase is how two waveforms are going to interact, or it's the time delay between two or more waveforms. And we're going to end up talking a bunch about this in some of the technical things, a lot of the processing, and in just basic recording, where we're going to be bringing phase, the idea of phase, into that a whole lot. So just remember that it's the relationship between those two waveforms. All right, decibel, dB. That's the unit that we're going to use to measure sound pressure level. Also volts. It's a very useful measurement, but it's not as straight ahead as maybe we would like it to be. There's a bunch of different scales that we're going to end up using decibel as the unit, right? So sometimes we'll be talking about 0 dB and 100 dB and minus 18 dB. Those are all, the same unit, but in different scales that we're dealing with them. And the next question is about a 1 dB change is noticeable to most people, but not by very much. All the time when I was mixing, I would have clients ask me, oh, turn that up 1 dB. Usually I would turn it up 3 dB and not tell them. But that's really what they wanted, was more of like a 3 dB boost to actually hear it. And then usually they like to tell me to bring it down half a dB, right? But so speaking of those things, the threshold of hearing is 0.0002 microbar, and that's barely anything. That's where we set 0 dB SPL. That's where we kind of start our hearing measurement. What people can actually hear is that the threshold of feeling where it starts to get uncomfortable. It's loud enough that it's there's discomfort in most people is 118 dB. And the threshold of pain where it will actually hurt, that would be 140 dB. Those are just guidelines, and I don't recommend running any of your own equipment at even at 118. You won't like it. Anyway, good. I hope that was helpful. That was quiz number 3. We will be back next week with quiz number 4. So thank you very much, and remember, like the kangaroo says, at these prices, I'm not surprised.